Yeah. So hello all. We will begin with this week's session. So this is week 10. We will be having 2 more weeks of this live sessions. So last week we were saying about intersection layout, and we will continue the same. So we stopped with question number 9, I guess. So we will finish the remaining questions and then we will start with the next week's questions. If you have any doubts, please stop me in between. As I always say, I'm Catherine Sanchna, a PMRF PhD scholar from IIT Madras. So if you have any doubts, please post in the discussion forum or leave it in the comments below um, corresponding to the YouTube video, okay, for that lecture. So the link to the YouTube video will be shared by the NPTEL team and can be found on the NPTEL website. So let us begin with this week's session without any further delay. Okay. So the first question, right turning lane at an intersection will eliminate what? So first let us understand what a right turning lane is and then we will proceed further. So if you see in a signalized intersection, okay, let us say it has 4 legs. So this is an intersection, right? This is an intersection which links the road in the north-south direction and road in the east-west direction. So this intersection has 4 legs. These extensions, okay, of this intersection are called as legs. And
Ma'am, there is no presentation.
oh, sorry. Thank you. Right. So, right turning lane at an intersection will eliminate what is the question. So let us first understand what a right turning lane is. Okay. So if you take an intersection of this type, you will call this as a 4-legged intersection. Why is it a 4-legged intersection? Because it has 4 extensions, one in this direction, one in this direction, one in this direction, and one in this direction, right? Vehicles will move in the north-south direction and in the east-west direction. So these 4 extensions are called as legs. If, for example, let us take a 4-legged intersection. The vehicles which move straight ahead, okay, are called as through vehicles, okay, because they go straight without making any turn. Now the vehicles which go to the right are called as right turning vehicles, and the vehicles which go to the left are called as left turning vehicles. And if you see, in India we have this concept of free left concept, right? But for right we do not have that concept, because since we are always moving on left, we have more provision, or we have more reasons for being given a free left than a free right. We cannot be given a free right because it will lead to collisions, right? So now the vehicles which move on the right are called as right turning vehicles. And if you see, in a signalized intersection, the vehicles, if you are a driver, you should be knowing about this problem. So if you are traveling in this lane, say it has 3 lanes, okay, if you are traveling in this lane, in order to make a right turn, you have to go cross all the way and go to the rightmost lane, right? And then only you will be making the right turn, right? So in some cases, in some signals, okay, first they will allow only straight vehicles to go. So if this is a 4-legged intersection, and let us say you get green for this leg, sometimes what they will do is either they will allow both the straight and the right turning vehicles to go in this phase, keeping the vehicles in the other legs as giving a red signal to other legs. Just a second. ஏடா டபடுபன்னு உருட்டிக்கிட்டே இருக்கேடா. Yeah. So you will be given green for this leg, and while all the other legs have a red, in such a case there is no need to provide a right turning lane exclusively. Mostly we won't provide a right turning lane for such cases, okay, because when the green signal is given, both the straight and the right turning vehicles can move without any further without any um, collisions, okay, without any reasons for going under a collision, okay. But if you in some intersections with signalized intersections, sometimes first they will allow the through lane to pass through, and then they will change the signal and ask only the right turning vehicles to pass through, okay. In such a case, it will be very difficult for right turning vehicles to cross and then make the maneuver, right. In such a cases, they will provide an exclusive right turning lane so that the vehicles can get accumulated here. The vehicles which plan to make a right turn get accumulated here, okay. We will call it as storage lane. We will see about the storage lane later. So in such cases, they will provide an exclusive lane for right turning vehicles to get accumulated so that when their turn comes, they can make the move, okay. So one such reason is when there's an exclusive right turning signal, then the vehicles should get accumulated here, and for that reason you will provide a right turning lane exclusively. Or as I said, if you are going straight, if both the through vehicles and right turning vehicles are provided with the same green signal, okay, if they plan to move together, then the vehicle on this leftmost lane has to go through this lane and then only make the right turning movement, right. In such cases, there it leads to a collision with the straight vehicles, okay, and that collision will be a rear end collision, okay. So the vehicle rear end collision is, as you can understand, the vehicle will get hit at the back, okay. So you provide a right turning lane with a view of eliminating rear end collision. This is explained by Sir, and it is there in his slides, okay. So this is what I was talking about earlier also. In one phase, they will allow only the straight or through vehicles, and in the next phase, they will allow only the right turning or left turning traffic or right turning traffic, whatever, okay. So the conflict points at a four-legged intersection would be minimum if the intersection is what. So I believe I am bound to explain what a phase is before we go to this problem, okay. So in the previous problem also, I was talking about signalized intersection without clearly describing what a phase is, right. So let us understand what a phase is. So it is a four-legged at grade intersection, right. So it is like this. Now a signal can have any number of can have any number of phases more than two, okay. Only then it will be a signalized intersection. If it has only one phase, then it will become an uncontrolled or priority intersection. So what do I mean by this is, so phase is the movement of traffic in the green time, right. A signal will have red and green, right. So each leg will have a red and green, okay. So if in one green, if two movements is made, that is vehicles move in this direction and vehicles move in this direction, okay, that will be taken as the first phase. Then let us say after this north south traffic will get a, so first they will get a red and then a green, during which they will make a movement in the north south direction, right. Now after that, they will get a green and then a red, right. So when the vehicles in the north south direction are at a stop, the vehicles in the east south direction will make a move, right. So this we will call it as second phase. Why I am saying only two phases is, after this again this will repeat. The vehicles only in the north south direction will move. After that, the vehicles only in the left east west direction will move, okay. So this complete thing is taken as one cycle, right? One cycle is in north-south direction, they will make a move, and after that, in the east-west direction, they will make a move. This is one cycle, because in the next cycle, again, the vehicles will be moving in the north-south direction first, and then in the east-west direction. So this I will call it as a two-phase signal, right? For a given cycle length, okay, cycle length is the summation of the green time till the entire process gets repeated, right? So now in the first phase, the north-south will make a move. After that, the east-west will make a move. So this is one phase, and second one is the next phase. After that, again the north-south direction will move. So since the process is getting repeated, the next cycle has started, right? So this is a two-phase signal. So what is a four-phase signal then? So in a four-legged intersection, you can have any number of phases. You can have 2, 3, 4, etc. Okay. So now if you have a four-phase signal, first you can allow vehicles. So in the first phase, you can allow vehicles. Say let us take this as north, south, east and west. Okay. So the vehicles moving in the through direction and the vehicles moving in the right direction so this can be taken as the first phase. In the second phase, the vehicles in the east direction can make a through turn and then a right turn and left turn also. Okay. So if you see for one green time, so if south has a green time, all the others will be having a red, and all the vehicles accumulated in this leg will discharge, right? So in the next phase, the vehicles in the east direction will get a green, and all the vehicles accumulated in the eastern leg will discharge, right? Now this is the second phase. After that, the vehicles in the north will make a move, okay, because it will have a green, all the others will have a red. Now after this, the vehicles in the west direction will make a move, okay, because it will have green. So this is the fourth phase. Now after this, it will again go back to the south, right? After east west, all the vehicles in the south direction will again move will get a green. Okay, so at the end of this west, you will call it as one cycle. Okay, this is one cycle length. And how many number of phases you had, how many number of greens you have? You had 4 number of greens, so it is a 4-phase signal. Now this is one way of giving a 4-phase signal. There's another way of giving a 4-phase signal, which is as shown in this figure. So in one phase, what you can do is, sorry, I don't know when I muted. I think I muted in between. Can you please tell me from when were you not able to hear? From which question?
Second question.
Okay. Thanks. Thank you. Okay. So long we were talking about four-legged intersections, and I will first introduce conflict points, and then we will go to phases, because this problem will require an understanding of conflict points and phases. So I don't remember if I explained about conflict points last time. So first we will go through conflict points. Okay. So what is a conflict point? Let us take a four-legged intersection. Okay. And let us imagine that it has one-way traffic, only one-way traffic. So only vehicles will be moving only in this direction.
Presentation, ma'am.
Is it not shared?
No, not shown.
How come? But before it was there, right?
Before, now it is not.
Okay. Thanks. Please keep telling me if I think there's some problem. So please let me know if you face any issues.
Okay.
Yeah, thanks. So let us so for this problem you will need an idea about conflict points and phases. So let us take did we see any problem on conflict points last time? Number of conflict points, does anyone remember? I remember having the problem, but I don't know if I discussed that with you. Okay, so let us take a four-legged intersection with vehicles moving in only one direction in each of the legs. Okay, and let us take a two-lane four-legged intersection. So it has two lanes, so vehicles will be moving in this direction in both the lanes, and vehicles will be moving in this direction both the lanes. Now they have only uh, one-way traffic, right? So now what do you think could be the number of so what is a conflict point? The conflict point is point where two vehicles traveling in a particular direction have potential probability of resulting in a conflict, right? So if a vehicle is moving in this direction and a vehicle is moving in the north direction, then there is a chance that they may undergo conflict at this point, right? So that point is called as a conflict point. Now it will so the number of conflict points will vary depending upon the number of lanes, the number of legs in an intersection, the number of the type of movement in the intersection. So whether it is a two-way traffic or whether it is a one-way traffic, so all will make an influence, have an influence. So if you see, when vehicles are moving in this direction, east-west direction, and vehicles are moving in the north-south direction, then there are, you can identify four conflict points. Okay, you can how you can identify these conflict points is simply draw how the movement will be and just mark the point where they intersect each other. So these four are conflict points, and they are called as cross conflict points because they cross one another at 90 degrees. Okay, there are two types of cross conflict points. One is a 90-degree crossing and another one is an acute angle crossing. So they won't cross exactly at 90 degrees, but they will cross like something like this, okay, making an acute angle with one another. So this is called as a cross conflict point, and cross conflict points are major conflict points. Okay, now what are the possible movements other than this? Other than this is the vehicles in this direction can make a right turn, right? So this is called as a merging conflict. Okay, so when they are planning to merge with the vehicles in the east-west direction, so when the vehicles in the north-south direction are planning to make a right turn and merge with the vehicles in the east-west direction, they might create a conflict when they merge. So that is called as a merging conflict, and the merging conflict points are called as minor conflict points. Okay, so if you see Sir's slides, Sir would have given many methods to reduce the number of conflict points. So how can you reduce the conflict points is, you can either give a rotary interchange. Rotary interchange is nothing but a roundabout. Okay, so it still has four legs, but you've introduced a round channelized island in between. Okay, so when you do this, vehicles will move around this roundabout, right? So it will kind of create a channelized movement, and this conflict points, especially the cross conflict points, can be eliminated. So one such way to reduce the number of conflict points is by introducing a rotary intersection. Okay, another way is you can introduce a signalized intersection. So what will a signalized intersection do? So when you make the intersection to be signalized, you won't allow all the vehicles to move at all the time, right? Say imagine you have this four-legged intersection and you give green to this leg. Okay, so this is called as a leg of the intersection, right? So when you give green to this this leg, vehicles will be moving in this direction, in this direction, and in this direction, correct? So when you do that, there's no possibility of the vehicles to conflict with one another, right? So that because there are no vehicles coming in the east-west direction, and even when they are planning to merge, there won't be vehicles coming in the east-west direction. So the number of conflict points can be minimized to a greater extent when you provide a signal. Okay, so what are the options that you see for this problem? You have a signalized intersection with two faces, signalized with multi faces, rotary, or an interchange. Interchange can also reduce the number of conflict points. But what is the question? The question is, it has to be an at-grade intersection. So when you provide an interchange, both the movements will be at different levels, right? So this option is eliminated. Now a rotary, so when I was explaining, I told you here the cross conflict points can be minimized in a rotary intersection, but there will be other minor conflict points also. Okay, so it is not reduced to that extent. So rotary intersection can also be eliminated. Now what are the, so I told you um, signalized intersection will reduce the conflict points to a greater extent, right? So in such cases, so now you have signalized two options for signalized intersection. One is a two-phase and one is a multi-phase. So first, to understand this, let us see what a two-phase is and what a multi-phase is. Let us take a four-legged intersection again. What do I call by phases? Say, imagine all of you would have traveled on the road and we would have all come across a signalized intersection. So let us say that you are standing here. Now you have a red signal. Okay. No, let us say you are here. You have a vehicle in front of you which just passed when it had a green signal. Okay. Now by the time it got red, you had come to this point. So now you just entered the intersection when the signal changed from green to red. Okay. Now after this, let us say this leg has a green. So after your green has stopped, this east west, this direction has got a green. Okay, so all the vehicles in this direction will move. After that, they will get a red, right? Now um, the vehicles in the north direction will get a green, so they will make a move. By that time, all the other legs will have a red, right? So after north, the green in the north direction is over, it will get a red, and the west leg will get a green. Okay, so all the vehicles in the west direction will move, and while all the other legs will have a red signal. Now after this west, what will happen? You will get a green, so you can make a move, right? So this is called as one cycle, because one cycle is over, right? After that, the process gets repeated. After that, you will get a green, again east will get a green, again north will get a green, again west will get a green, right? So this entire thing is called as one cycle. And if you see, in each cycle, you had four greens, of which all of which had different movements, right? In one green, only vehicles in this direction moved. In the other green, only vehicles in this direction moved, right? So like that, you had four greens in which different movements were made, and this is called as a phase. Okay, so this is called as a four-phase signal. Now what will happen in two-phase signal? There will be only two greens, right? You had four greens here at different times. So imagine a cycle. It would have four greens, right? At different instants of time. So that is called a four-phase. Now, if you go for a two-phase signal, let us say uh, you are allowing, let us say there is no right turning traffic in this in this four-legged intersection. Okay, so in such cases, there's no, so only when you have a right turning traffic, if you allow the traffic in both the directions to make a pass, then they will undergo a conflict point, right? So this might get hit with the vehicles in this direction, right? So in such cases, mostly they will go for a four-phase intersection, four-phase signal. Okay. Now, if there is no right turning traffic, what is the need for them to divide it into four phases? It is a waste of time, right? You should reduce the delay of the travelers, delay of the vehicle users as much as possible. So if you ask them to wait simply for no reason, when there's no right turning traffic, there's no need for them to give four phases. So what they will do is they will provide one green in which vehicles in the north-south direction will make a move. Okay, so south vehicles will go to the north vehicles will go to the south. So this is one phase. After this, the vehicles in the east-west direction will make a move, while vehicles in north-south direction will have a red. So this is the second phase. Here, if you see, there are no conflict points, and the time has also reduced, right? So this is a two-phase signal. This is for when it does not have a right turning traffic. What it has a right turning traffic, and what if it has only two phases? In such cases, you will have conflict points compared to a four-phase signal, right? In four-phase signal, you're allowing traffic only. So even if you see this, this is also a different kind of four-phase signal. So this is also a different kind of four-phase signal, where first you allow vehicles in in the opposite directions to come, second east-west direction to come, then you will provide movement exclusively to. So since this is based on US, I guess they have provided exclusive phase for left turning traffic, right? In our case, we will provide exclusive lane for right turning, not lane, exclusive phase for right turning traffic. Okay, so this is also a four-phase signal. If you see, can you identify any point where that there could be a possible conflict? No, right? But the same thing you provide for a two-phase signal which has a turning traffic. You will provide a movement, so you will provide one phase like this, right? So it will create conflict points here, right? So which is better? The conflict points will be minimized when you have signal with more than two phases. So this can be a three-phase also. They can also make it into a three-phase depending upon the volume of through vehicles and turning vehicles, right? So it can be 2, 3, 4, etc. Of which 2 is the least number of phases that could be provided. If you provide one phase, what will happen? It will just become an uncontrolled intersection or a priority intersection, right? So a two-phase signal has conflict points, whereas if you keep on increasing the number of phases, the number of conflict points will reduce. So of the two options given here, the one which will reduce the conflict points to a major extent will be signalized intersection with multiple phases. Okay. So now moving on to the next problem. The objective of channelization of an intersection is what? So you know that all these are channels, right? So this is a channel, this is a channel, the rotary island itself is a channel, right? So why they are asking you, what is the reason for you to provide a channel? So the first reason will be to separate the directional movement, right? Only then, so you are guiding the traffic to move in a specific direction. So the first reason will be this, and the second reason is if it is a multi-lane road, you are kind of providing a provision for pedestrians, okay, to cross this part of the road, then wait here and cross the remaining part of the road. So most of us will do this in a on a median, right? So median is also a channel. So you will cross one side of the road and then you will stand on the median. I'm talking about this, not a raised median, but a curb, a median with a small curb, right? We will stand on this median and then we will make the move. So we will cross the remaining part of the road. So a channel will also, so a channelized island is also provided for this reason. So it is in no way provided to improve the aesthetics of the region. So if you see a channelized island, it is for these two purposes. And improve drainage. A channelized island will not improve drainage, but you should provide provisions in the channel so that the drainage of the road is maintained. Okay, so even if you see a road with a channel with a median in between, you should provide provisions in the median so that water will get drained off. So this will not improve the drainage of an intersection, but when you provide a channel, you should make sure that the drainage provisions has to be made for drainage. Okay, so the two reasons for this will be, yeah, so the two reasons will be, one second. Only provide pedestrian refuge on a multi-lane road and separate the directional traffic. Okay, so based on traffic consideration, the correct sequence of upgrading a priority intersection is what? We know what is a priority intersection, right? So when a major road crosses a minor road, we will always ask the vehicles on the minor road to provide a priority to the vehicles on the major road, which means vehicles on the major road need not stop and they will keep on moving, whereas the vehicles on the minor road will have to adjust their movements based on the vehicles on the major road. So they will come here, stop, look to the left and right, and then only cross the road, right? So this is a priority intersection. So what are the ways by which you can improve a priority intersection? What is the sequence? So sequence as in how will you um make it more safer. So there are many ways for making this intersection as a safe intersection, right? You can provide an interchange, like you can take the two crossing roads and provide them at a different level, or you can provide a signal, right, so that the safety of this intersection can be improved. But you won't do the signal, you won't provide signal immediately. You will first try to see if you can provide the most least cost. If so, you will look for options to make it safe based on cost effective options, right? So you will always go from a lower level to higher level. You will first check at the lower level, and if it does not satisfy, if the safety concern is not satisfied at the lowest level, you will go to the next highest level, right? So they are asking you what is the sequence with which you will make this move. So first, what will happen when you have a priority intersection? First, what you can do is you can provide a stop sign or a yield sign. In this way, you can tell the vehicles on the minor road to be more careful on their own, right? So the first will be stop or a give way sign. Okay. Next one will be to provide a channelization. So what is a channelization? We saw already. A channelization, a rotary interchange is also a channelization. So when you provide a rotary interchange, the conflict points will be reduced. So first you will just implement signs, and after that you will implement channels. Okay, so the second option is channels, and third option is signals. So this will, we saw that compared to rotary, signals will reduce the conflict points to a major extent, right? So the next highest safety providing measure is signalization. So after that comes signalization. And what is the final resort for reducing the number of conflict points, and which is the most costly resort, is providing an interchange. So they will always keep this interchange as the last resort. Okay, so the correct order is give way or stop sign, install give way or stop sign, then try to provide channelization, then go for signalization. If channelization is not enough, you will go for signalization, and if signalization is not enough, you will go for service interchange. Okay, so this is the order. So grades separated without ramps is an intersection where through traffic on a major road is what? So we saw what an interchange is. Interchange is when vehicles are at two different levels, right? Either one can be at the road level and the other crossing road can be at the higher level, or one can be at the road level and the other crossing road can be at the lower level, or a combination of all these three. Okay, so these are called as grade separated interchanges. Okay, they are separated by grades. Okay, if they are all on the same level, well, then we will call it as an at grade intersection. So this is all known to us. Now they're asking you, so this grade separated intersection itself is of two types. One is with ramps and one is without ramps. So what do they mean by with ramps and without ramps is, so if it is with ramps, it means that the vehicles on the ground level can access the vehicles on the upper level or lower level by ramps. We know what a ramp is, right? By ramps. So if one road is here and the other road is here, okay, this is plan view. Okay, I'm not showing elevation. So if they are both, so these both are at two different levels. So if you provide vehicles on a provision, if you give a provision for vehicles moving in this north-south direction, the change to the east-west direction, imagine north-south direction is in a ground level. Okay, and this is at a higher level. If you give a provision for vehicles in this direction to move to the east-west direction, you need ramps for that, right? Ramps is an inclining road, an inclined road. So if you provide a connection from one road at a lower level to one road at a higher level, obviously it will be inclined, and that is what we generally called as ramps. Okay, so the English definition of ramps is, right, this, or the civil definition of ramp is this, right? So when you do this, you will call this as a grade separated intersection with ramps. And what do I mean by without ramps? Without ramps is two roads are crossing one another and vehicles do not have access to the other road. To come to the other road, either some other provision would have been provided, but not at this intersection. Okay, but not at this region. So this is called grade separated ramps without grade separated interchanges without ramps. Okay, now so they are asking you, what is a grade separated intersection without ramps, where where the through traffic on a major road will move for a grade separated intersection without ramps. So as I told you, it is just crossing and you cannot deviate to other directions, right? So this option is not the answer. You cannot go from one direction to the other for without ramps. And it does not talk about anything saying whether it should be at the ground level or whether it should be at a higher level. Without ramps is two roads crossing one another at different levels. That's all. So if you see, this one is also not an option, and segregated at two to three levels. So what we saw, two roads at different levels crossing one another. It can be in two levels or it can be three levels, like this, right? Or one is in the ground level, one is in this, one is in just above that, and you also have one above that. So it is actually four levels, right? So it is segregated at two or three levels. So this two to three levels. So this is the correct option. Okay. Column 1 lists the types of intersection and column 2 lists is the broad category of intersection. Right? So if you see, there is diamond interchange, which is what I've shown in this figure. There is Y-shaped interchange, which is what I've shown in this figure. Y-shaped is not an interchange. If you see, it is an intersection. Okay. Whereas a diamond will be an interchange. They will be at two different levels and they are provided with ramps. Okay. And what is this? This is a flyover. A flyover is simply two roads crossing at different levels. It is simply nothing but a grade separated intersection without ramps. That is a flyover. Okay. So now you have been asked to match column 1 and column 2. So let us go from flyover. So flyover, as I said, it is a grade separated intersection without ramps. Okay. Just two roads crossing one another at different levels. No connection between the two. So C is 2. Flyover, Y-shaped intersection. If you see the figure itself, you can understand that a Y-shaped intersection is not an interchange. It is an at-grade intersection. Both the two roads are in the same level, right? So it is an at-grade intersection. So B is 1. And D is a service interchange. So we saw what a service interchange is. Okay. And a diamond interchange is an example of a service interchange. So it comes under 3. So the correct answer is B. So read the statement A and B related to ramps provided at an interchange. Statement A is ramps facilitate entry from and exit to minor road. Deceleration and acceleration lanes are provided on the ramps. So let us first see the first statement. Ramps facilitate entry from and exit to minor roads. So what we saw ramps are roads connecting the two crossing roads, okay, which are at two different levels, right? So it can be like this, ramps can be like this. Ramps can be provided as loop ramps. There are many ways of providing ramps. So either they can provide an entry to the other road, from this road to the other road, or they can provide exit from the top road to the bottom road, anything, right? They are just helping you to access one another, right? The vehicles on one road can access the vehicles on the other road, which is at a different level, and vice versa. So it helps in the entry and exit to minor road. So it need not be only minor road, it can be any kind of road. Okay. So for this example, they say it as a minor road. Now there's what is statement B? Statement B is, so this seems to be correct. Statement B, acceleration and deceleration lanes are provided on the ramps, right? So let us first understand what an acceleration and deceleration lane is. I think I explained it yesterday, last week. So what is an acceleration lane? So if let us imagine that this is a ramp which connects vehicles in the north-south direction. Let us take this as a minor road, okay, which has a speed of 50 km/h. Now it has to come and connect to a major road. So this is a major road which has a speed of 80 km/h, right? Now in such a case, the vehicle speeds will have to match, right? If not, it will cause an issue. It will either lead to an accident or it will reduce the efficiency of the major road in the east-west direction. So what it will do is, first the vehicles in the traveling in the ramp at a speed of 50 km/h will enter the acceleration lane, where they will increase the speed from 50 to 80 and then enter the major road which has vehicles traveling at the speed of 80 km/h, right? So even if you see in this figure, acceleration lane is provided at a constant level and it is not provided as part of a ramp. So it should not be provided on the ramp, but it should be provided after the ramp ends along with the major road, okay, but kind of extended from the major road. So option statement B is not correct because these so similarly for deceleration lanes, vehicles moving in the major roadway have to reduce their speed. I don't know when I lost this connection and what is happening. From when did you face this issue? If you tell me from when you faced this issue, then I can come again. Repeat the question once again.
Seeing that channelization, some signalized channelization, interchange.
Which one?
Next slide. Next slide, madam.
This one.
Yes, madam.
Yeah, yes.
Okay. So there are two types of two columns. Okay, you've been asked to match the two of them. This is a diamond interchange. This is a Y intersection, not an interchange, because the vehicles in this, if you see, all the roads are in the same level, so it is an intersection, at grade intersection, and not an interchange. And this is a flyover. So a flyover is nothing but two or three roads crossing at different levels, but they do not have access to one another, which means they are simply grade separated intersections without ramps. They are called as flyover. So if we go through this problem, so flyover, as I said, it is a grade separated intersection without ramp. A Y intersection is nothing but an at grade intersection, and a diamond, we saw what a service interchange is, and diamond is an example of a service interchange. So the answer to this is option B. Okay, so if you see this problem, the next problem, they are asking you to state which of the statements are correct and which are wrong. So let us read the first statement. So one is, ramps facilitate entry from an exit to minor road. Let us take two roads which are crossing at different levels, and I told you that a ramp is used to connect one road to the other, one road at one level to another road at the other level, right? So it can be a minor road or a major road, there is no issue, but ramps help you to facilitate either entry from a minor road to a major road, or exit from a major road to a minor road. Okay, so the first statement seems to be correct. The second statement is, deceleration and acceleration lanes are provided on the ramps. So last week itself we saw what an acceleration and deceleration lane is. Okay, so if you have a ramp connecting a minor road at a speed of 50 kmph and a major road at a speed of 80 kmph, you know that vehicles from the minor road which are at 50 kmph cannot simply enter the major road with vehicles traveling at 80 kmph, right? When they do this, this might result in a conflict, that is accident, or it will either reduce the speed of vehicles traveling it will affect the flow of the vehicles on the major road. So what needs to be done is, they will provide an acceleration lane where after the ramp the vehicles will enter the acceleration lane and increase their speed from 50 to 80 kmph in this distance, and after that only they will enter the major roadway. Okay, so this is called an acceleration lane, and the opposite is for a deceleration lane. Vehicles traveling at 80 kmph, if they want to connect to a minor road with vehicles traveling at 50 kmph, then they will enter the deceleration lane, reduce their speed, and then only enter the ramps. So in both the cases, if you see, both the lanes are provided along with the major roadway, which are at the same level, and they are not provided on a ramp, right? Ramp will have a increasing grade or a decreasing grade, right? Whereas deceleration lane and acceleration lane will have the same grade or a constant grade and flat grade. So in such cases, if you see, or this is the case, and if you see, statement B seems to be wrong. So the answer to this is statement A is correct, but statement B is incorrect. Now moving to this week's problems. Okay. So consider the following data. You have an intersection and you have vehicles traveling in. So they've given you the vehicles per day in the major road and minor road. Okay. So you have 4 intersections. Let us take, this is intersection A, B, C and D. Let us take vehicles in east-west direction, road on the east, in the east-west direction as major road, and road in the north-south direction as minor road. Okay, so they've given you the number of vehicles per day on the major road, okay, in this direction, which is for each intersection, and number of vehicles per day in the minor road, which is the north-south direction, okay, for all the 4 intersections. And they've also given you how many number of crashes have occurred in each of these intersections per year. Okay, so which is this. Now they are asking you to find out, okay, they are asking you to arrange these intersections based on the increasing order of their crash frequency. So as the term, from the term itself, you can understand that crash frequency is the number of crashes that occur in a year. Okay. Now you cannot simply take simply take crash frequency as number of crashes divided by number of days or number of vehicles, and so there is a specific formula to find out crash frequency, which is number of crashes per year divided by traffic volume on major road. Okay, let us take this as capital N into crashes traffic volume on minor road. Let us take this as small m. Okay, and this should be written in thousands. So let us see what it means. So we saw it is the number of crashes divided by okay. So if you have number of vehicles in the major direction as on the major road as 49,000, you should not substitute it as 49,000. You should substitute it as 49. Okay, that is what the formula says. That is why in the formula itself I have introduced this, which means you simply have to divide the number of vehicles by 1,000 before you use it in the or after you use it in the formula. Okay, so let us first calculate it for the first problem. Okay, for intersection A, it is 147 divided by root of 49 into 32.5, right? And this will give me 3.68. So the answer to this is 3.68. B, 82 divided by root of 43 into 90. And the answer to this is 2.87. C, for C it is 101 divided by 37.5 into 31, which is 2.96, and D, 65 divided by 32 into 11, which is 3.46. So you're asked to arrange it in increasing order, right? So what is the lowest? Lowest is B, then comes C, then comes D, and then comes A, right? See, if you see, you cannot simply say based on these yearly crashes just by, so what is the order, just by looking at this yearly crashes, it is D, B, C and A, right? But you cannot give the ranking of the crashes at a given at frequencies based on this, only based on this yearly crashes, because you also have to know the number of vehicles traveling in that intersection, right? So to make this more clear, let us take two intersections, okay, A and B. Let us take two intersections, A and B. This intersection has close to total of 1000 vehicles traveling, and this has a total of 500 vehicles traveling. And say this has number of crashes as 100, and this has a number of crashes as 75. Now you cannot say A is the worst intersection. Why? Because out of 1000 vehicles traveling, only 100 vehicles have resulted in crashes. But here, out of 500 vehicles which are crossing this intersection, 75 are prone to crashes. So you cannot simply compare the number of crashes to rank an intersection, but you should also compare it with the number of vehicles that travel on the intersection. That is why the crash frequency has a formula involving number of vehicles on the major and minor road as well. Okay, so this is the ranking. Final answer B, C, D, A. Now moving on to the next problem. Intersections shall be provided on multi-lane highways where the grade change in the profile of crossing roads is more than what? So you have two crossing roads, and one has a grade of say 1%, and the other has a grade of say 4%. Then in such cases they say you have to find out the grade change of the two crossing roads, and if it is more than 2%, then you should probably avoid intersections. Okay, so this can be found out in sir's lectures. Okay, so the answer is 2%. You have to, so in fact in the slides it is all many other points along with this have also been given as to when intersection should be avoided. So please go through that, okay, along with this. So moving on to the next problem. So if you see IRC3, okay, you can see these kind of trucks, and each will have a separate name. Okay, they say that these are the probable when IRC3 was written, these were the probable these are the kind of trucks that they were able to identify. But now we are seeing different kinds of trucks as well. But let us first stick on to IRC3 and see what these trucks are, how are they called. This is a single unit truck because it is as you can see, it is a single unit. Now this has two units, but the second unit is not fully detached from the first unit. So this is called as a semi-trailer truck. Okay, so these two are called as semi-trailer trucks because they are not fully detached, right? Unlike this one. So this is called as a tractor trailer combination. Okay, so they have different names, and each of these vehicles will be used to design an intersection. Okay, and for this question they are asking you, for a major road what is the design vehicle, right? So if you see, for rural roads, okay, for major roads they use semi-trailer truck as design vehicle for an intersection, at an intersection. Okay, if an intersection has a minor road, then they will use single unit trucks. Okay, So so the design vehicle will vary depending upon the type of road and the type of usage. So design vehicles we would have already seen earlier. um, for If you see, for pavement design, I would have said the design vehicle is vehicles more than 3 tons, weighing more than 3 tons. For traffic, the design vehicle is passenger car unit. So car is the design vehicle, so they convert all the vehicles to a standard car. And so in the same way, for geometric design also, depending upon the geometric element, the design vehicle will keep changing. So for such a case, for this case, for intersection, for my major road, the design vehicle is a semi-trailer truck. So both 2 and 3, B and C, are the answers to this question. Now column 1, the next question is, column 1 represents the factors which affect intersection design, and column 2 represents their categorization. So what do you think will be the probable factors that could affect the intersection design? Okay, they have identified 5 factors, which are these. Okay, now you have to see which factor of column 1 will fall under column 2. Okay, so there are 5 factors: human factor, traffic factor, road factor, environmental factor, and economic factor. Now by looking at column 1, we'll try to map where each of these factors will fall under. Okay, so intersection density. Can anyone guess where intersection density will come? Under which factor will it come? What is intersection? And so if you see so if you understand what intersection density itself, you can identify the factor. So what is intersection density? On a given road, they're asking you how many number of intersections are there per kilometer, or the distance may change. Okay, so density is it has to be normalized with something, right? So here they are normalizing it with distance. So intersection density is number of intersections on a roadway per kilometer or per unit distance, some distance. Okay, so as I said, it is part of a road. Intersection density is part of road characteristic, so it will fall under road factor. So intersection design will fall under road factor. Operational cost, as the name clearly says, cost refers to economic, right? So operational cost comes under economic factor. So the answer to this is E. Perception reaction time. We saw much earlier the PIEV theory, where we saw how this perception reaction time is calculated or identified, right? So what is perception reaction time? The time taken for you to perceive the situation and then react to it. So it is obviously a human factor. So 3 corresponds to A. Traffic composition, as the name clearly says, traffic composition corresponds to traffic factor. B. Type of development. So type of development is if there's a roadway, and what are the type of developments adjacent to it. So what in that environment of the roadway, what types of development can you see? You can see they will affect the intersection design, right? So that will come under environmental factor. Apart from these, on the left hand side, there are many other factors contributing to, there are many other criteria, or there are many other points that come under each factor. Let us say for human factor, apart from this perception reaction time, you can have driving habits of drivers, ability to make decisions, pedestrian use, and all that. Okay, driver expectancy, right? traffic factors, if you see, what did you see here? Traffic composition. Apart from this, you can have vehicle speed, traffic mixes, traffic composition. You can have vehicle crash experience, design or turning movements, okay, types of movements, all will come under traffic factor. Road factors, intersection density is what we saw. It can also have side distance, angle of intersection, geometric features, safety features, available right of way, okay, all this will come under road factors, and many more. Okay, environmental factors, character and use of abutting properties. So what is the type of property which is close to the roadway, what type of what lighting equipment do you use, what are the environmental features of the road, okay, all this will come under environmental factors. And economic factors, you will have cost of improvement, change in cost of operation of traffic, okay, all this, anything related to cost will come under economic factors. So the answer to this will be D. Okay, I hope you can see my slides still. Oh. Now an intersection, so this is a problem. An intersection is to be provided with right turn lane and a through lane. We already saw what a through lane is and what a right turn lane is. Okay, so even if you see this figure, this you will take it as a through lane, because vehicles will directly go straight. Okay, vehicles which are planned to go straight will occupy this lane. This is a left turning lane. Vehicles which plan to take a left turn will get accumulated here, and this is a right turning lane. Vehicles which plan to take a right turn will get accumulated here. Okay, now they're asking you to provide, so an intersection to be provided with a right turn lane and a through lane. The width of the storage lane is 3 meters and the transition is done at a rate of 1 in 15. A signal is installed at this intersection with a cycle time of 2 minutes. So the vehicular data is given below. They are asking you to find out the length of the storage lane. So if you see, this is the distance taken for tapering, right? This median has to get tapered and provide some distance, and after that only this will get cleared and which will form one lane, right? So this tapering is what they say as 1 in 15. Okay, you have to neglect this. After this, from here, no, sorry. So this is the tapering that they provide, okay, and this is the actual storage lane that you find out. So the total storage lane length will be summation of these two. Okay, so they are asking you to find out what is the length of the storage lane. So before that, let us see what a storage lane is. Okay, so storage lane is nothing but an auxiliary lane. So what is a storage lane? It is a part of a lane. Okay, it is an extra lane required to accumulate maximum number of vehicles, okay, during the peak hour. So to accumulate the vehicles during the peak hour. Okay, so this is a storage lane, and I told you, when there is a right turning traffic, if you provide a lane exclusively for right turning vehicles, then the efficiency of the intersection can be improved a lot. Okay, so usually, so since in our place we provide a free left turn, or left turn doesn't cause any conflict, we have this keep left criteria. So we will provide separate lanes only for right turning traffic. So here for this problem they have designed, so traffic volume for right turning traffic and through traffic in vehicles per hour. Okay, and this is the length of each vehicle, so length of each type of vehicle. Okay, so the formula to find out length of storage lane is summation of number of vehicles in one cycle in one cycle. So we already saw what a cycle is, right? For a signal, into proportion of traffic into length of vehicle. Okay, first you have to find out each value, multiply each of them, all three together, and then sum it up. Okay, so let me draw a table. Okay, now we have vehicle, you have length of each vehicle, they have given you that. They've given you just a second. They've given you design our traffic for right and through. Okay, so design our traffic, this is right and this is through. Proportion of traffic you're supposed to find. Again, this is for right and through. And after that you have to find out length of lane. Again, this is for right and through. Okay, so this, you have four types of vehicles: car, bus, truck, and LCV. Right. So they've also given you the length of all these vehicles: 4.5, 11, 10, 5.5. So what is the design traffic that they've given you for left turning traffic and through? It is 280. Okay, so which means there are 280 cars which make a left turn for that given hour. 280, 25, 15, 40. And for through traffic, it is 370, 50, 40, 50. Okay. So now they're asked to find, now you've been asked to find out proportion of right turning car amongst all the right turning traffic. Now let us write the formula once again here so that you will know why we are finding out all these. So it is nothing but, length is nothing but summation of number of vehicles in one cycle into proportion of traffic into length of vehicle. Right. So now you have proportion of traffic. Okay. How will you find out proportion of traffic? So proportion of right turning car amongst all the right turning vehicles. So for that you have to find out the total, right? Only then you can get how much percentage of right turning car is there in the total right turning vehicles. So this is 360 and this is 510, right? Sum it up. Now how will you find out the proportion of traffic? 280 divided by 510 into 100, and that will give me 77.78%. Similarly, it is 11 this is not 510, this is 360. Okay, right turning means right turning traffic, right? So this is 25 divided by 360 into 100. This will give me 6.94%. Similarly, you have to do the same. It is 4.17%. 11.11%. Now come again to through. So this will be 370 divided by total number of through vehicles is 510 into 100. This will give me 72.55%. Similarly, if you do the same, so 50 divided by 510 into 100 will give me 9.80, 7.84 and 9.80 again. Right. Now, how will you find out the length of the lane? You know that you have to find, so summation is separate, right? Summation is just finding separately for each row, and then you have to add all these up, right? So first you know the proportion of traffic, you know. Length of the vehicle also you know. What is something that you do not know? Is this is number of vehicles in one cycle, right? So what they've given is number of vehicles in an hour, and they are asking you, so in the formula it has number of vehicles in one cycle. So you have to find out number of vehicles in one cycle. So they have given you cycle time as 2 minutes, right? Cycle time is 2 minutes. How many number of minutes in an hour? In 1 hour you will have 60 minutes. Okay. So how many number of cycles you will have in an hour? You have 2 minutes is the cycle length, and you have 60 minutes in an hour. So the number of cycles in an hour per hour will be 60 divided by 2, which is 30. Okay. Now you found out what are the number of vehicles, what are the number of cycles in an hour. Now the question is, how many number of vehicles so in the equation you have number of vehicles in one cycle, right? But what they've given you in the question is number of cycles in 1 hour. So if you have 30 number of cycles in 1 hour, then whatever the number of vehicles that they've given you, okay, the total which is 360, okay, that you will divide it by 30, because this is for 1 hour and this is for number of cycles in 1 hour. So if I do this, I will get number of vehicles in one cycle. Okay, so this is what you want. So 360 by 30, so this is for right turning traffic. 360 by 30 you will get 12, and for through traffic you will get 510 divided by 30, which is 17. Okay, so for this formula you have everything. So how will you find out the length of the lane? Length of the lane is, for first row it will be number of vehicles in one cycle is what? For right traffic it is 12 into proportion of traffic is what? 77.78, so it is 0.77 into length of vehicle is what? 4.5. Okay, let me check it once again. with my calculator. So 12 into 0.77. Okay, I'm not getting the answer which I have got. I will just check it once again and I will explain it to you next class. Okay.
Ma'am,
Yeah.
ma'am,
Yeah, yes.
number of vehicle in one second. Not take, we should not take total, madam.
Your voice is breaking. Can you please talk a bit clearer?
Total vehicle we cannot take. Individual vehicle we can take.
Total vehicles?
We are taking total vehicle.
Hello?
Number of vehicles taking total, madam. 360 we are taking, madam. Instead of 360, we have to take individual vehicle, madam. 280 divided by 30. 25 divided by 15 divided by 30. Like that we have to take.
Okay, but even if I take that, I'm not getting the answer. So it should be
Summation, madam. Summation.
no. I have answers for each row also. That answer I'm not able to meet. 1 second.
280
280.
divided by 30
1 second. 280 by 30.
into proportion of traffic into.
So proportion of traffic is 0.77, right?
Yes, ma'am.
Into 4.5.
Yes, ma'am.
Still I'm not able to get. 1 second. Yes, no. You should divide it by total traffic only. Why? Because for that only I'm multiplying it by proportion, right? You understood? Hello?
Yes, madam. Cycle covers both through traffic and right turning traffic. We have to take total traffic.
Yes, you have to take the total traffic. In order to bring it down to cars only, I'm multiplying it with proportion of traffic. So it has to be 12 into 0.77 into 4.5. What do we get? It is 41.58, right? So I'll check it once again. So it is 12 into 0.77 into 4.5. Yes, so it is 41.58. I've taken it as. So obviously cars cannot be in um, this number, right? Fractions. So I'm taking it as a whole number. So it is 42. Now after this, I'll do the same for remaining also. So for the next row, it will be for right turning traffic for bus, it will be 360 into proportion of traffic is what? 0.069 into length of traffic is, length of bus is 11. So that will give me into 0.069 into 11. So that will give me sorry, this is not 360, this is 12, right? 360 divided 12. So this will give me 9. Similarly, for truck it will be 12 into 0.041 into length of vehicle is 10. So this will give me 5. Similarly, this will give me 4. Okay, now moving on to through traffic. So this will be what is number of vehicles in one cycle? It is 17. So 17 into percentages, proportion is 0.72 into length of vehicle is 4.5. So this will give me 56. Similarly, you do the same thing for other vehicles also. So it will be 17 into 0.098 into 11 will give me bus. 18.33. Sorry, this is just the length of lane, right? So it can be a fraction. It is not number. So it can be a fraction. 13.33 and 9.17. So what have we done? We have found out for each vehicle. What is the formula? It is the summation for all the vehicles. So for each vehicle, for right turning traffic, I have found out what is the storage length required. So what is the total storage length? It is the summation for all the vehicles. So I have to for storage length for based on right turning traffic, it has to be sum of all the values on the that we just found out. 42 plus 9 plus 5 plus 7. 9 plus 5 plus 7. So this is the total for storage lane length for right turning traffic. Okay. Now what is the answer for what is the length of storage lane for through traffic? It is the summation of all these. So 56 plus 18.33 plus 13.33 plus 9.17. So this will be 96.33. You can take it as 97 meters. Now, they asked you to find out the length of storage lane, and they gave you two types of traffic. One is right turning traffic and one is through traffic, right? Of the two, so you got different lengths of storage lane for right turning traffic and through traffic. For right turning you got 64 and for through you got 97. So which one you will pick? You will pick maximum of these two. So length of storage lane you got it as lane you got it as 97 meters. Now they have given you one more thing.
Now why it's a storage lane is different and through lane is different. We are calculating length for the storage lane something 64 something. Why should we adapt the through lane 97 meters? Because it is separate, no? Through lane is separate and storage lane is separate. Because storage lane we have 12 cycles, 12 vehicles I think per cycle.
Maximum right, sir. Otherwise, after 64 meter, it is difficult to take right hand, sir.
So for right turning traffic, it is only 12 vehicles per cycle.
64 right turning for right turning 64 is enough, sir. But for vehicle beyond 64, they have to take right turn. For that space is not there, sir. Otherwise, if it's not provided as 97, it is difficult to take right turn, sir. Beyond 64 meters, so maximum only required.
Okay.
Your question seems to be valid, but here it is the total length. I will confirm, or I will just go through some literature and I will try to find out why they are taking through traffic. Both
Because
arguments
through
are
traffic
valid.
will be on the separate lane.
Yes, through traffic will be on separate lane.
Storage will be on separate lane.
Yes.
So we are calculating storage lane based on the vehicles per cycle on that particular lane only. Why we are considering through traffic lane 97 as a storage lane?
Initially in the same length, both the right turning vehicle and the through vehicle will come, sir. Initially, sir.
No, not initially. The storage lane only for the right turning vehicles.
Sir. The storage is only for right turning vehicle, but for total length on 64 plus 97, sir. Suppose if right turning vehicles are coming back, suppose it is coming, they have to take right turns. They will not take.
So through vehicles can also occupy the storage lane. You want to say?
No, yes, no, sir.
Yeah, tell me.
Or maybe this is the case. Say through vehicles need 97 meters and right turning vehicles require 64 meters.
Yes, yes.
Yes. And what if all the through vehicles come and occupy this lane? As he
exactly.
was arguing, yeah. If all the vehicles come and everything is saturated, so 97 meters is occupied.
Okay.
How will the right turning vehicles will cross
so
this and
the
go
storage
to
lane gets the vehicle from the through lane only, sir.
Okay.
So the maximum length has to be provided up to the through lane.
Only then, even if the entire length is saturated, even if right turning vehicles come, they can make the movement to the storage lane, right?
Yeah, understand. Yeah. Thank you.
Thanks. Okay, so now we found out only the length of this portion. We saw that it has a tapered portion where the median will get tapered and provide way for this storage lane, right? So this length also needs to be calculated as length of the storage lane. So we saw that it is provided in a tapered section of 1 in 15. So for one for one width, 1 meter in the horizontal direction, the vertical direction, the distance in the vertical direction is 15 meters. Okay, since it is a 3 lane, okay, so it has to have 3 times of 15, which is 45. They already told you that the length of the storage, the width of the storage lane is 3 meters. So the tapering value, that is the rate at which the transition is done, is for 1 horizontal it has to go 15 vertical. So since the width of the storage lane is 3 meters, the total width will be 15 into 3, which is 45 meters. So this distance has to be provided in the, so for this tapered direction, the total vertical will be 45 meters. Okay, because this entire width is 3 meters. So now the total length of the storage lane will be this 94 meters plus 45 meters, which will be 142 meters. Okay, I hope this problem is clear. I will also solve the problem and add it in the drive. Okay, so moving on to the next problem. The design speed on highway is 80 kilometers per hour. The minimum length of acceleration and deceleration respectively would be what? We already saw what acceleration and deceleration lanes are. So they have also given you a table to help you decide the minimum length of the minimum acceleration lane length required. So if you see, this is the speed on the highway. From this speed, okay, so this is the speed on the highway, and these are the speeds from which they have to gain their speed and reach the final speed on the highway. Okay, so if you see itself, if the speed is 0, then to reach 80 kilometers per hour, it needs the maximum distance compared to all the other speeds. Similarly, if the speed is 20, okay, let us take for example 100 kmph. If for the vehicle to reach speed from 20 to 110, it requires just 470 meters, not just 470 meters, it requires 470 meters. Whereas if the speed has to go from 0 to 110, it requires a much higher distance, right? So if you see, it will be of the decreasing order. Now they are asking you what is the minimum acceleration length. So if you see for this figure, what is the minimum? For 80 kilometers per hour, the acceleration length is in decreasing order, right? And the minimum value that is given is 50 meters for a speed corresponding to 60 kmph. So the answer for acceleration lane, minimum length of acceleration lane for design speed on the highway as 80 kilometers per hour is 50 meters. Similarly, we go to deceleration lane. So for speed on the highway as 80 kilometers per hour, okay. Now from 80, it has to go to 0. If it has to go to 0, it requires 130 meters. From 80, if it has to go to 20, it requires only 120 meters. It is just the opposite, okay. From there, it has to come from 0 to 80, 20 to 80 for acceleration lane. For deceleration lane, it will be the opposite, from 80 to 0, 80 to 20. But still, the length required, the relative change in the length required across the different speeds will be the same, right? It will keep decreasing with increase in speed. So if you see from this figure itself, from 80 to reach 65 kilometers per hour, it requires 50 meters, which is the minimum of all the deceleration lane lengths. So the answer to this is 50 meters. So if you go back, the answer for minimum length of acceleration is 50 meters and minimum length of deceleration is 50 meters. So the answer is 50 and 50 meters. Now moving on to the next question. The length of the deceleration lane is 120 meters for an intersection designed at level grade. Okay, for level grade, the deceleration lane is 120 meters. If the deceleration lane is laid at a downgrade of 1 and 25 meters, okay, this is not a ramp, okay. The deceleration lane itself has a gradient. If it has a gradient of 1 and 25 meters, they're asking you what would be the change in length of the deceleration gradient. So if you see, there is a formula to convert. So if this is for a level section and they're asking you what will be the length if a decreasing gradient is given. They are asking you to multiply this distance, okay, by the formula 1 plus 60 times of the gradient in percent. Okay, so what is 1 by 25 in percent? Just multiply it by 100, you will get 4%, right? So you have to multiply this formula. So what it actually means is the actual distance plus whatever is there, this actual distance into 60 times, 0.6 times of this grade. This is the increase in or change in the deceleration lane length. Okay. Now one question which is interesting is, you know that if you have a down gradient, the stopping side distance, what will be how? So if you have a stopping side distance of s in a level on a level grade, if you go on an upward gradient, your stopping side distance will be less than s, and if you go on a downward gradient, your stopping side distance will be greater than s, right? Stopping side distance will be greater than s. If you see this problem here, the length has increased. Why it has increased? Because you actually have to drop from say 80 kilometers per hour to say 50 kilometers per hour for which you require a distance of only 120 meters. Now you're decreasing the grade, because of which, see, if your grade is increasing, no, it will be easy for you to reduce the speed from 80 to 50, for which the length of the lane will decrease, because you will bring down the speed at a much shorter distance than required, because your increase in the grade will help you with that. Now your grade is decreasing, and it will be difficult for you to bring down the grade from 80 to 50, because yeah, because it is a downward gradient, it will be, because of the action of gravity, it will be very difficult to bring down your speed from 80 to 50 in this 120 meters, for which you have to increase the length of the deceleration lane. So similarly, for upward gradient also you have a formula similar to this, but there you will use a negative value, because a minus sign, because as I told you, a deceleration lane with an upward gradient, it is easy to reduce the speed if it is against the action of gravity. Whereas if it is towards the action of gravity, then it will require a longer distance than what is required on the level grade. So this is just some basic theory behind it. But the actual values can be found out by using this formula. Okay. So this is the last question which we will be seeing today. After this, we will meet next week. So this is a corner island. To show an example of how a corner island will be on the road, I've shown this figure. So this is kind of a T intersection, and in order to channelize the movement, they have provided a corner island. Okay, like this. Okay. Now so this, which has been given to you, A, B, C, D, in IRC, they've given you what should be the values of this at these points. Okay, value of angle at these points, or the value of the distance at these points. Okay, so for reference, we will go to that figure and try to match it with this figure. Okay, so they're asking you to match these A, B, C, D with the maximum values, right? So if you see this figure, first let us see A. A was here, and it was 0.3 to, so it is 0.3 to 0.45 meters, of which the maximum value is 0.45 meters. So for A, the maximum value has to be 0.45 meters. For B, it is, so the offset, this distance, okay, should be between 0.6 to 0.9 meters. So for B, the maximum is 0.9 meters. For C, they have not given you a distance, but you can simply identify that it will not be in fractions of meters, but it is a much higher value. But let us leave this for now. Let us come back here to D, because we have the value for D. So for D, it is 0.6. So this D is 0.6 to 0.9 meters. Sorry, D is this. D is this offset. Okay, so it is 1.2 to 1.8 meters. The maximum is 1.8 meters. So D is 1.8 meters. This is B. Okay. D is 1.8 meters, which is 3. And C is the rest, which is 9 meters. Okay, so the answer to this will be C. So let us end this session. Do you have any doubts? If you have any doubts, please ask me. If not, we will end this session. So shall we end this session?
Yes, ma'am. Yes, ma'am.
Okay.
Thank you.
Thank you.
Thank you. Thank you.